of what you all talked about yesterday, which was hopefully somewhat of an introduction to basic function uses. For today's class, it's going to be a really short lecture because we're only going to talk about one concept, and that's what's on the board right now, closure. So yesterday we talked about how functions are just like other things, are just like any other data type in JavaScript, right? In the sense that we can use it as an array, we can put it in an array, we can treat it as a variable, etc. And so today we're going to kind of complete that puzzle by saying, well, if we know we can use a function as if it was a variable in every other context in terms of passing it in somewhere or using it, well, it also stands to reason that we can also return it as well. So here on line 3 through 5, we have a simple function that returns back a string. On line 7, when we execute that function, returns a string. That essentially, the right-hand side of that equal sign essentially converts to I am a string, and we capture that value in the return value variable. Okay, so very basic function that returns a string, and the whole point is to show you that, well, guess what? We can do this with a function equally as well. So here on lines 1 through 3, we have a function called greetMe, and all it does when it runs is the console logs out hi. And on line 5, we have a function called getGreeter, and when that function runs, it returns the greetMe function. Now, one really important thing to note here, okay, on line 6, when I say return greetMe, I'm not saying run the function and then return whatever it gives me, right? And I know I'm not asking you to run the function because on line 6, look at that. After greetMe, there's no open and close parentheses. In JavaScript, the only way to run a function is with the open and close parentheses, which means you're invoking a function. And so on line 6, if I was only looking at line 6, I actually don't even know what greetMe is, right? It could be a number. It could be a variable pointing to a number or a string or whatever, right? On line 6, all we're saying is, hey, return this variable to me. And when we look on line 1, we realize that that greetMe variable is pointing to a function. And what that function does is console log out hi. So the big thing I just want to kind of point out here is on line 6, 1, we are able to return a function as if we were returning any other data type like a string or a number or a boolean. That's totally fine. And secondly is on line 6, based on the way the code is written, we are returning the function as a variable. We are not running the function just yet. Okay. On line 9, here on the right hand side of the equal sign, you see us actually invoke the getGreeter function. And so what does getGreeter do? We go back to line 5, which takes us to line 6. getGreeter returns back the greetMe variable, which is a function. So therefore, on line 9, the right-hand side of the equal sign basically boils down to getGreeter returns the greetMe function, so therefore the right-hand side of the equal sign is the greetMe function. And so line 9 becomes let the variable greeter equal the greetMe function. And so now when I do type of greeter, and when I console log out greeter, and more importantly on line 13, when I actually invoke greeter, in all three cases, greeter is basically the function, greetMe. So on line 11, the type of greeter, well, we know is a function. On line 12, when we console log it out, we'll see on the printout it says function greetMe. Ignore the brackets. That doesn't mean it's an array. This is just kind of how functions print out in JavaScript. So just from this, just take it to mean that it's not an array. It's just a function called greetMe. And most importantly, on line 13 there, when I invoke the greeter function on line 13, that is the same as me invoking the greetMe function from line 1. And that's why I see the console log of hi. Okay. Now, the difference between this example and this following one on this page is everything else looks the exact same, except the main difference now is on line 6. Notice how now I actually do have the open and close parentheses after greetMe. Okay, so what does that mean? That means on line 6, I'm no longer asking you to return me the greetMe variable or the greetMe function. What I'm saying is, hey, run the greetMe function first, and now it has to be a function, right? Because if greetMe was a number and I tried running a number, well, JavaScript at some point will probably give me an error saying, hey, you can't do that, right? So therefore, on line 6, when I look at the greetMe and the open and close parentheses after it, I know at this point greetMe has to be a function, and I'm asking, or rather on line 6, we're asking the function to run greetMe first, and then give back whatever greetMe returns. Okay, so this is a very, very important distinction here, right? Because in the previous example, we just gave back the function as is. Now we're saying run the function first and give me back whatever the function returns after you ran it. Okay, it's almost like saying like like if we imagine greet to be like a gift box, right? If we tell someone, hey, give this person this gift box, well, it's a very different thing for you to give the person the box without opening it than after you opening the box, taking what's inside the box and just giving it to that person directly, right? In the previous example, we just said, here's a variable, give it to whoever asked for it, right? That's the equivalent of someone giving you a wrap box and saying, hey, pass this box to someone else, and you doing that. Here on line 6, what we're doing is we're actually saying, hey, here's a box, unwrap it first, right? Use it, get whatever it returns, and then give whatever it returns to whoever asked for it, right? So now when I give you a box, we're actually unwrapping it first, taking whatever's inside the box, whatever the return value is, and only giving that to whoever asked for it. So on line 6, when we invoke the greet function, what does the greet function return? Well, when we look through lines 1 through 3, we don't see a return statement in the function. And so this is once again a good reminder to let you know that in JavaScript, every function always returns something. And if you don't tell it explicitly what to return, then by default, every function is going to return undefined. And so therefore, when we invoke the greet function, we get back undefined, right? Console log is just something to print out to the humans to see. It doesn't return any values. And because the greet function doesn't return any value, it by default returns back undefined, and so line 6 becomes return undefined. Okay, so when I invoke getGreeter on line 9 there on the right hand side of the equal sign, now getGreeter boils down to undefined, and on line 9 we're saying let greeter equal to undefined. So now when I console log out type of greeter, and also on line 13 when I try to invoke greeter, I get back undefined at every single instance. So when I look at the printouts, the hi is invoked because of line 6 because I invoked the greet function. The line 11 there, type of greeter, undefined type is still undefined. If I console log out greeter, it's undefined. And lastly, on line 13, when I try invoking greeter, that's basically me trying to invoke something that cannot be invoked. And so JavaScript gives me back a type error in this case saying greeter is not a function, aka you're not allowed to invoke it. This makes sense to people so far? Everyone good? Any questions?
So whenever we set up a variable to a function, we can't invoke it by just putting the parent next to variable?
Exactly. Whenever you assign a function to a variable, you can use that variable exactly as if you would use a function. Cool?
Thank you.
Yep. Any other questions? We only have 2 big ideas today, and this is one of them. So I'm just gonna pause for a little bit, see if there's any questions before we move on.
So if the function greet me, if that was actually returning something, would line 6 then, sorry, when you invoke the function getGreeter, would that return something at that point?
Yep, it absolutely would. So if between lines 2 through 3, if I had returned the number 5, then on line 9, getGreeter becomes 5.
Gotcha.
Yep. Right now, the undefined is only being passed through because in the greet function, lines 1 through 3, we don't return anything. If whoever was writing that function was, I guess, in this case, more intentional and puts a return statement there, then that's what will get returned at every stage. Remember, computers are highly, highly logical things, right? If anything, they're actually a lot easier to understand than people because there is no kind of sense of ambiguity or randomness. With any function you ever see, if you just logically trace it backwards, like you will reach a point in which either you didn't tell the computer to do what you thought you did, or more commonly, you're basically like misunderstanding how a computer is doing something behind the scenes, right? So if I put a return statement in the greet function there, that will pass back to line 6, and that will pass back to line 9. Cool. All right, so this is just a way for us to return functions from functions. And obviously, once we kind of get our minds around that, then it becomes a lot less about functions, and now we're just kind of playing around with variables now, right? Here on line 1, notice how we have a getGreeter function, and now we create the greet function inside of getGreeter. But on line 7, we're still just returning the greet function, right? And once again, when we look at greet on line 7 there, greet is a variable, it's not being invoked. So as far as I know, I'm just returning back almost what we call, what in CS we call a dumb variable, as in it could be anything, right? As a user, I actually don't know what I'm getting. It's a dumb variable. So all I know is on line 7 is give back the greet me variable. It could be a number, it could be a string. In this case, if we look upwards in our code between lines 3 through 5, we see that it's a function. But the point here is that it doesn't have to be a function. It could be anything. And so here on line 10, when I say let greeter equals get greeter and we invoke it, we go to line 1, then line 3 through 5, and then finally on line 7, we return a variable, we return the greet me variable. So on line 10, it's the same as saying let greeter equal greet me. And so when I invoke greeter, that is the same as me invoking greet me. And we console log out hi. Okay. And then this is almost the same exact idea, except now it's a semantic. Rather than saying, hey, let's name a variable, or rather, let's declare a function and capture it in a variable. Here on line 3, we're actually using JavaScript's arrow syntax to just very easy saying, hey, let's just return a function directly. And I apologize if the arrow function was tripping you up. Just know that we can also do something like this too. Ignore the color coding. This is also equally fine as well. Okay, same idea, right? It doesn't matter how we declare it. Here we're just saying is, rather than saying let x equal 6 and then the next line return x, we're just saying return 6, right? So here, rather than saying let variable x equal this function and then return x, we're saying, hey, let's just return the function directly. And so on line 3 there, once again, we see the open and close parentheses, but notice that's because that's part of the function declaration. That's when we're creating the function. Nowhere are we running the function. And so similarly on line 8, when we say like greeter equal whatever get greeter returns, get greeter is still equal to the function that we're returning on lines 3 through 5. So when we invoke greeter on line 9, it's once again the same as us invoking that anonymous or that unnamed function from lines 3 through 5. And then because we are treating this just like any other function, our rules on parameters still holds, right? So here on line 3 through 5, I'm returning an anonymous function. The function takes in a variable called name and it console logs out hi name. And so therefore on line 8, when I invoke get greeter, I'm returning a greeter on line 8, let greeter equals the anonymous function from lines 3 through 5. And whenever I invoke greeter, it's the same as me invoking the anonymous function, which is the same as me having to invoke it by passing in a string into it. In this case, when I pass in Marie, it prints out hi Marie, hi Rosalind. And then on line 12 there, just notice when I don't pass anything into JavaScript, well, that variable is not going to throw an error. JavaScript is just going to say, hey, I expected something here, I didn't get it, so for now I'm just going to leave it as undefined. As in, here's a variable, it hasn't been created, or rather it's been created, but it hasn't been given a variable yet. Let me just use undefined for now. And so therefore when I look at printouts, I see hi Marie, hi Rosalind, which makes perfect sense. But then last but not least, we see this undefined, which basically just means, hey, on line 3, really, or rather on line 12 there, we should have been passing in a variable or passing in a value, and we didn't. And therefore the function on line 4 is saying, I'm looking for a name parameter. I know one exists, but you haven't given me a value for it yet, and so therefore by default it's going to be undefined. Okay, all this is saying that if your function takes in a parameter, it doesn't matter if you're using it in the original function form, it doesn't matter if you're capturing it in a variable and then calling the variable, you still pass in parameters the same exact way in both scenarios. Okay, any questions on returning functions from functions before we move on to closure, which is in some ways an extension of this idea? Okay, awesome. Okay, so now let's take another look at scope before we move on to closure, and that's because closure is actually a way for us to kind of almost circumvent some of the things that we've actually learned about scope last week or maybe the week before.
I'm sorry, real quick. It looks
Yeah.
like Joe B had a
Oh, wow, thank you for that. Totally not see that. Joe B. Okay, so Joel's question: is it possible to have multiple anonymous functions within a functions, or would that cause problems? Great question. Typically, the point of an anonymous function is usually when you create an anonymous function, it's a function that's going to be used once or in one place because you're not storing it anywhere. Usually, like once you use it once, you can't get access to it again by definition. So the short answer to your question is no. It's not an issue when you have multiple anonymous functions, right? That's totally fine. The bigger concern there is, well, it's not an issue. It's not going to break anything. But it's kind of like if you're going to create an anonymous function, I guess if you're using it once and just kind of leaving it, maybe that's fine. But usually we don't see a lot of anonymous functions being declared simultaneously, right? The thing with the return statement is return will only return one thing. So actually, I take that back. So one way that your question could actually be kind of in a more valid use case would be someone wanted to create an array of, let's say, 3 elements, and each of those 3 elements was an anonymous function. Then that would be totally fine. There's no limits on the amount of anonymous functions you're creating. Creating an anonymous function is almost like capturing a variable that you quote unquote lose access to unless, of course, you store it somewhere. Thanks for the question, and thanks for reminding me. Okay, I'm already sharing my screen, I believe, right? Cool. Yep. Okay, cool. So quick recap on scope. So remember how when we talked about scope, the idea behind scope essentially is it's the analogy that I always use, and it's kind of a very common one. Is kind of like a sandbox. Like in a scope, like it's kind of like this is your sandbox. You can use whatever's inside of this, but you can't use whatever's inside of other people's sandboxes. And so the way that scope worked is scope is in our case is defined by the curly braces. And usually the idea is if I'm looking for a variable, I look within my nearest set of curly braces first. If it's not there, then I'll look in what we call our parents scope or our parents or the next highest set of curly braces, and so on and so forth, all the way until we get to the global scope. And if by the time we get to the global scope, we still can't find a variable, then that means this variable does not exist. Okay, so the first kind of, or rather, there are several rules to scopes, right? The first rule is we always look in our own scope first. The second rule is if we don't find in our own scope, we'll look outwards in our parent scope and parent scope and parent scopes, eventually all the way until we get to the global scope. And then the last kind of big rule on scope that we covered essentially was we can't look in our children's scope. As in here, if I look at this example on line 6 through 12 there, if I create a function, or sorry, if I create a variable uh, between lines 8 and 9, then that means that that variable only exists in the says hi function, and the greeter function does not have access to it because we cannot look at other people's scopes that are inside of us. Okay. However, in this example, in the says hi function, when it looks for a name, it looks for it in its own scope first between lines 8 through 10. It can't find it. So then, because in scope, the idea of scope is you can look more and more outwards. Then on line 9, we actually look outwards to the greeter scope on lines 6 through 12, and we find a variable called name on line 7. Okay, so the analogy that I always give here is another analogy I give here is the deal of kind of like the way that like you would ask for money in some ways. Like if you need money, like typically speaking, you will look in your own bank account first, right? That's your own scope. And if you need to borrow money, you will borrow it from, like in this case, like your parents. And then if that doesn't work out, you can borrow from your grandparents and great grandparents and so on and so forth, right? What you wouldn't do is you wouldn't like go to the bank accounts of your kids and get the money from there, or you wouldn't go to your siblings' bank accounts and try to get money from there. Obviously, families differ, so like this is think of it as more of kind of like a maybe a funny example and less of like a hard and fast rule. But that's the way that I've always thought about scope in terms of kind of what scopes do I have access to and which ones maybe I shouldn't have access to. Okay, so that's scope. And once again, the main idea here is that, well, if I define a variable inside a function, it means I can access it within that function. But people outside of that function do not have access to it. Okay, so what closure is closure is actually a way for us to kind of circumvent that. It's a way for us to have it's a way for us to be able to use a variable even when we're outside of the scope of that function. So what does that look like? Well, let's take a look at this example here. On line 1, we create this function called getGreeter. On line 2, we console log out getGreeter is running. On line 4, we create a variable called name, give it the value Marie. Then we acknowledge getGreeter is finishing. And then on line 8, we return an anonymous function. And all that function does is console logs out hi, comma, name. Okay. Now, oh, sorry. This is a comment I made before. Okay. So on line 13 there, we still invoke getGreeter. Okay. And so when we invoke getGreeter on line 13 there, we're going to go through line 2, line 4, line 6. On line 8, we finally return the function. So on line 13, it's basically saying let greeter equal, and then the anonymous function on lines 8 through 10. And then on line 14, we're actually invoking that function. And when we do, we see the printouts. On line 13, when we invoke getGreeter, we see our 2 console logs. getGreeter is running, getGreeter is finishing. On line 14, when we invoke greeter, we go to line 8 through 10 there. On line 9, we console log out hi Marie. Now, this may seem very simple at first, but the really kind of, maybe if you're nerdy, like awesome thing about this is if you look at the variable called Marie, it's created on line 4, which is in the scope of the getGreeter function on lines between lines 1 through 11, right? We create a variable called Marie in between functions, in between lines 1 through 11. Typically, what that means is no one outside of the getGreeter function, no one outside of lines 1 through 11 should have access to that variable Marie, because we created that variable inside of a function scope. But look where we invoke greeter. We invoke it on line 14, outside of the getGreeter function scope. And yet, by invoking that function even on line 14, even outside of that scope, we were able to say hi Marie, as in we were able to read, or in this case, access that value. So now the question becomes, how and why does this happen? Well, this is the idea of closure, right? Closure, it's based on the word enclosed, and the basic premise of closure is that a particular function's scope is determined based on where it was created, not where on it is being used. Okay, so let me say again, closure just means the scope of a function is based on where it was created, not where it was used. Okay, so the anonymous function on lines 8 through 10, it was created on lines 8 through 10, and therefore its scope almost encloses or has closure upon all the variables that it had access to from where it was created. Okay, because of that rule, on line 14, even though we're using this anonymous function outside of the getGreeter function, even though we're using that function outside of the scope that it was made in, the function still has access to the scope based on where it was created. And so therefore, even though we're using it on line 14, it's as if that function was still on lines 8 through 10. And because of that, it was able to access the name variable. Okay? And so that's why closure is really powerful, because now we've almost created a way to export our variable, or at least give functions in other places a way to use our what we call private variables, right? Like inside getGreeter, I create a variable that by default can only be used by me and my children. But through the anonymous function on lines 8 through 10, I'm now saying, hey, I'm going to return a function, and this function is going to be able to access the same variable no matter where you use it. And so that's the point of closure, is the idea that like now we can actually have a way to take a variable inside a function scope and give other people outside of the scope access to it. So here, if I take a look at another example now, on line 2, we see a function called getGreeter, and it takes in a name. On line 3, all I did for for our discussion is I've added a comment there, and basically all that comment is saying is that is basically the same as saying, sorry, let me go through. Okay, sorry. On line 2, we define a function called name. Ignore the comment on line 3 for now. On line 4, we return the function, and all it does is the console logs out hi, comma name. So on line 9, when we invoke getGreeter and we pass in Rosalind, on line 3, that's basically saying, hey, within this getGreeter scope, let's create this, basically saying, let's have a variable called name and set it equal to the value Rosalind. And so therefore, when I invoke greeter on line 10, that's the same as me invoking the anonymous function that was returned to us on lines 4 through 6. And when I console log out hi name, even though we're invoking that function on line 10, Clojure basically makes it as if that example is, or rather that function still exists between lines 4 through 6. And therefore, when I console log out hi name, it's the same as us console logging out hi Rosalind. And then this is just another example of the same exact idea. We're just kind of trip you up with basically more parameters, but just know that if you just follow the very basic rule that, hey, whenever JavaScript sees a function or sees a variable in a function, it will always look in its own scope first and then look gradually more and more outwards, then you should be totally fine. Here, all we're saying is let's return a function in which we're taking a name2, and we console log out hi name1 meet name2. Now notice how on line 8 I create a function called getGreeter, or rather we invoke getGreeter, we pass in Marie. So now Marie is name1, and then whatever we invoke greeter on line 9 there, it's the same, basically saying, hey, whatever name we pass in, that will be name2, but name1 will always be Marie, right? Because if we look at the function on lines 3 through 5, from that perspective, name1 will always be Marie. And so this gives us a really powerful way of saying, hey, we can actually create multiple instances, or rather we can create multiple functions, and within each function, we can have a different value being attributed to name1, right? So on line 7, I invoke getGreeter and I pass in Marie, and I store that I store that variable. So that function is going to return a function, and that on line 7, getGreeter, when I pass in Marie, that's going to return a function to us, and to that function, name1 is always going to be Marie. On line 8, I call the function again. I call the getGreeter function again. I pass in Rosalind, and now that function is going to return a function, and to that function, name1 is always going to be Rosalind. And so now on lines 10 through 14, you see us being able to use this in different ways, right? So now I have two different functions, introduce Marie to and introduce Rosalind to. They're both made from the same function, if you will. They're both made from calling getGreeter, except in each instance, we're passing a different value as name1, and the functions that get returned will each think that that value is name1, right? It's almost like imprinting in some ways. So now when I say introduce Marie to, that anonymous function will say, well, what's my name1 value? Well, in my scope, name1 is Marie, so it will always be Marie, and the same for Rosalind, except now it thinks name1 will always be Rosalind. Okay, that's pretty much it for today's lesson. So any questions?
Sorry, I'm not understanding how name2 and name gets differentiated from name1 in this Clojure example.
Yep. So notice how name1 is based on if you look at line 1, name1 is based on what gets passed into getGreeter. Okay. So name1 in our case, for let's say introduce Marie to on line 7, name1 is based on what we pass into getGreeter there on line 7 and line 8. Okay, so let me just add a few comments here, it makes it easier. Introduce Marie to, name1 is equal to Marie. Okay. When we invoke it down here, when we invoke getGreeter again and we pass in Rosalind, well, now we're basically saying, hey, name1 is equal to Rosalind. Okay. Now when we invoke getGreeter, the getGreeter returns this function. And this function takes in another variable called name2. And so whenever we invoke this function, then we need to pass in another variable, and now that variable becomes name2. So here, when I introduce Marie2, well, name1 is still equal to Marie, but now name2 is equal to Dorothy. And similarly, down here, when I introduce Marie2 with Albert, name1 is equal to Marie, but name2 is now equal to Albert. And the same concept applies here as well to these two examples down here, except in this case, name1 was always going to be Rosalind, and now name2 is going to be Barbara. And the same for the line beneath that. Does that help?
Well, yeah. So basically, if you pass in the parameter, it just takes that parameter and just throws it into this inner function.
Yeah.
Because you never really stated what goes where.
What do you mean? What goes where?
So basically, when you pass in the introduce Marie to equal that to the get greeter function, you pass in Marie, and then the second time around you just introduce Rosalind to Barbara. I'm sorry, it's introduce Rosalind to, and then it passes in Rosalind. So name1 is Rosalind, I understand that, but name2, I'm still not understanding how that got there.
So name2 is so here, let me just put a so let's just use introduce Rosalind 2, right? Introduce Rosalind 2 now, if I just print it out, it's now equal to this function. Except name1 is now going to permanently be hi Rosalind. Okay, so after we run line 7, this is what we see, right? Introduce Rosalind 2 is basically equal to a function that takes in a name2 variable, and it console logs out hi, and it used to say hi name1, but when we create a get greeter, we're telling it, hey, Rosalind is your name1 variable. So now it just knows, let's plug in Rosalind here, and then we can say hi Rosalind meet, and then whatever name we pass in here is going to say meet whatever name2 is. And so if I scroll down a little bit further now in my I probably should have done this in REPL. I'm just going to delete this really temporarily.
Hello?
Can you guys hear me?
Yeah. So you're just declaring a function. So let's say on line 6, let introduce.
Hello? I'm sorry, you think whoever was speaking just cut out?
Hello?
Yeah, can you hear me? Sorry, can you say that one more time?
Okay, so yeah, just so we're clear, on line 6.
Yep.
So you're declaring a new function, introduce Marie to, using the function get greeter Marie. So you're already passing in Marie as name1.
Yep.
So you're that new function that you're declaring, you're using the function within that anonymous function, that return function on line 2. So that wait, so is that how? Sorry, I can't really articulate myself, but am I right as far as along those lines?
Yeah, I think I. Okay, so let me just say that. So let's say let x equal this.
Yeah.
And then here it's like return x. Maybe this makes it a little bit easier. Maybe the anonymous function is kind of tripping people up, and so maybe let's just get rid of that for now. So if I get rid of Marie 2 and let's just go with Rosalind for now. Okay. Introduce Rosalind 2 is equal to get greeter, and we pass in Rosalind, right? What happens when we invoke get greeter? We take in a name1, which in this case we take in as Rosalind. We say we create this function called x. We assign a variable called x, and this function just says hi name1 meet name2. It's always going to get name1 from its parent get greeter function, and then we return this function. So now introduce Rosalind 2 becomes this x function, except now we've plugged in Rosalind for name1. And so whenever we call introduce Rosalind2 and we pass in Barbara, that's us passing in the name2 value. And so here it would console log out, hi Rosalind, meet Barbara. Right? This is returning a function. Okay. Notice how here, getGreeter, it returns a function. We are not invoking this function. It is just returning the function. We're not running this function until all the way down here on line 13, right? When we have introduce Rosalind2, and we actually invoke it with the open and close parentheses. On line 8, on this side here, we are never invoking x. We're just creating x, and we're telling x, hey, by the way, going forward, no matter where you are being used, name1 is always going to be Rosalind. Better? Yes? More helpful?
Yeah, it's a lot better. But in the original example, was that line 10 there, introduce Rosalind2 and then equals function name2?
So let me just undo everything I did here, and we'll go back to the, okay.
Okay.
Oh God. Wait. Oh, sorry, it skipped a few. Okay, sorry. This was the original example. Yep.
Okay.
Yep.
Okay, so you have to pass in the outer function, make that permanent, and then you can pass in the second one after it's been defined. And then, okay, that kind of makes sense.
Yeah. Remember this. Don't let this confuse you, right? This function, if I up until line 9 there, this function has never been invoked a single time.
Right.
Right? It's being returned. It's being captured in these variables, and when we invoke these variables down here and down here, these are the only times that we actually invoke this function. And so when we invoke, so let's just say like introduce Marie2 is equal to this function here. Let's invoke this function, right? Let's say on line 10, we invoke introduce Marie2. Well, the function's gonna say, okay, I take in a name2 value and we give it Dorothy. So far so good. It console logs out hi name1. Well, when introduce Marie2 looks for a name1 variable, it looks for it in its own scope first, and between lines 2 through 4, we see at no point do we define name1 variable. So then Clojure says, well, based on where you were created, look in your parent scope. So its parent scope is now lines 1 through 5. And is there name1 variable being created? Yep, it was created whenever getGreeter was first invoked, and it was invoked in this case with Marie. And so it will say, hi Marie, meet name2. Well, does a name2 variable exist in its own scope? Yep, it does. It's based on whatever was passed in. And in this case, it was Dorothy. And so that's how introduce Marie2 outputs hi Marie, meet Dorothy, right? At every single step, it looks for whatever its version of name1 and name2 is. Name2, it's easy because it's whatever we called it with. Name1 is just a little bit trickier because now we have to see what name1 was based on where it was created, or based on what name1 was when it was being created.
Okay.
Yeah, that makes a lot more sense.
Awesome.
Good. Thank you.
Yeah, no problem. Any other questions?
Hello.
Yep.
Will you be uploading this right away?
Done? Yeah. YouTube usually takes about 10 minutes to process 20 minutes to process a video. So whenever it's done processing, I'll upload the links.
Yeah, and
sorry, just to clarify, that's me uploading the videos. You already have access to these slides as well as every slides we've ever gone over. Let me know if that's not the case.
Okay, and also.
Hello, sorry.
Lecture video. It was pretty in depth. Yeah, and there's like a lot of material.
Mm-hmm.
But if she could upload that would be awesome.
Cool. You mean from yesterday's lecture?
Yeah, yesterday's lecture.
Yep, I will ping her now.
Yeah. Okay, thanks so much.
No problem. Awesome. Okay, so this is hopefully gets you kind of get started on the idea of Clojure. And yeah, so feel free to get started on the workshop. We'll be here to answer questions. It's confusing to think about, but once you get it, like actually is fairly intuitive. It's just a matter of is now when you see a function being used, you'll say, the scope of that function is not where it was used, it's based on where it was created. And the return a function thing, that's just pure practice. Like after a while, you really will see functions as just like any other variable types. The only difference here is that, obviously functions can be run, which is the one thing that other data types cannot do. And so that's why we kind of draw it out, why we kind of almost put it on this pedestal, at least for our understanding. But in reality, like you'll soon be able to use it kind of very, very, very fluidly as well. Cool. So I will stop the share, and then I will get you broken up into groups. And then